Okay, today we are going to look at solving um, radical equations. Let me get rid of some of these markings. And basically, your radicals could be representative of square roots or cube roots, or whatever kind of root is denoted. If you don't have an index noted in your equation, so if it's not an index there, that's understood to be a square root. If it's something there, like here we have a cube root, that's indicative of a different root. What this means, square root is the same thing as the 1/2 power. So those are equivalent. Your goal is to get x out of this grouping symbol here. You're trying to get x equals. Every time you solve an equation, you want to end up with x all by itself. But right now, x is trapped. So you have to get rid of this power that's trapping it. So you need the reciprocal power. So if you raise this to the second power, now what you do to one side of an equation, you have to do to the other. These cancel when you multiply the exponents, and you have exactly what was in the group. And on the other side, you have 5 to the second, which is 25. Then you have a very simplistic equation. Subtract your 1, x is 24. And there's your answer. Now, it is wise with radical equations to go back and check your answer every time. So you could just take 24. 24 plus 1 is 25. The square root of 25 is 5. It does check. This is a legitimate answer. So when you come over here for the cube root, now you don't have to go through this transitional step if you don't want to. You could come straight over here and you say, well, to get rid of the cube root, I need to raise it to the third power. Okay. So the third power cancels out the cube root, and I get x minus 2 equals, now I've got to raise 10 to the third. That means that's going to be 1,000, because 10 times 10 times 10. I get 3 zeros at that point. Add 2 to both sides, that's 1,002. Well, if you wanted to check it, put 1,002 up in there. 1,002 minus 2 is cube root of 1,000. Yes, a cube root of 1,000 is equal to 10, so our answer checks. This, again, is a legitimate answer. So all you're doing is the reciprocal of your root. Okay? So if it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. Okay. When they get a little bit more complicated, you have to remember to check, because you will end up with what's known as extraneous roots, which means you have extra answers. Basically, when you check them, they don't work. So be very, very careful, especially when you end up with 2 solutions. It's very possible that one of them will not work and one of them will. I have seen it before where both of them do not work and you have to cancel them both out. And you have no solution, so just be careful. All right, so just some more examples. If you happen to have something over here with your root, before you can square both sides, you have to isolate the radical. So this 2 needs to move, because you're trying to isolate this portion, which means get it by itself. So if you move the 2, we're right back where we were before. So I've got my radical by itself. It is a square root, so I square it both sides. And the square and the square root cancel. I get what's underneath. 4 squared is 16. You just got a traditional equation at that time. Move the 2 over, divide by 3, x is 6. It would behoove you at this point to check your answer. 2 plus 3 times 6 is 18 minus 2 equals 6. So 2 plus the square root of 16 equals 6. So 2 plus 4, yes, that works. So it is a legitimate answer. Keep it. All right, come over here, do the same thing. I have to move my 6 first before I go through and cube. Don't lose the cube now. It means something totally different if you lose your cube. Alright, you're going to cube both sides. The cube and the cube root cancel out, and I've got 5x plus 1 equals, now 6 times 6 times 6, I do believe it's 216. Alright, if I take 1 away, I've got 215, and then I have 215 divided by 5. I'm going to type that in because I don't know it off the top of my head. 43. Once again, it would be wise of us to check that. Cube root of 5 times 43 plus 1. Now that's all underneath, so I need to extend that. So make sure that you end your radical in the appropriate place. Don't get sloppy. I need to close my parenthesis. So this is going to end up being that 216 that we had up there. So the cube root of 216 minus 6 equals 0. That right there is 6. 6 minus 6, yes it is. So this is a perfectly legitimate answer. Okay? Now, let's upgrade just a little bit. This is where it becomes important for us to understand the rational exponent, that the square root is equal to the 1/2 power. That's what you're doing, is you're trying to get your power of x. You want it to end up being x to the 1. That's your goal, is x to the 1. So, let's just start working through these, and we'll see how they go. Same thing as before. You see this 2's on the outside? You've got to get rid of him first before you can even start contemplating this fractional exponent or the rational exponent. So let's divide through by 2. Don't get distracted by the rational exponent. That's going to leave x minus 2 raised to the 2/3 equals 25. Okay, now you have the group raised to the rational exponent. That's your focus now. To cancel that out so that you can have access to the x, you want the reciprocal of that power, which is 3/2. Well, again, what you do to one side, you must do to the other. 3/2. Now, remember, if you have a rational exponent, the top number is the power, and the bottom number is the root. So this is the square root of 25. Get that number and then cube it. Now, if that hurts your brain, get a calculator and type it in. 25 raised to the 3/2 power. But it would be great if you could just do the square root of 25 is 5, and 5 cubed is 125. I would always go small first and then make it big, because if I tried to do 25 cubed and then take the square root of that, it would make my brain hurt. Go small first. Over here, everything should work lovely. These cancel out, or basically they simplify and reduce down to 1, which is what you're after. And so you've just got x minus 2. Move your 2 over and you got 127. You can go through and you can check this. 127 minus 2 to the 2/3 power equals 50. So that's going to be 125 to the 2/3. Okay, now the cube root of 125 is 5. 5 squared, 5 times 5 is 25. So 2 times 25, is that 50? Well, yes it is. So our answer is good. All right, if you come over here and you start working with this problem, you still have this 2. It's multiplied by 2. You've got to get rid of it first. Okay, 54 divided by 2 is 27. Now you get to focus in on your rational power. So you want to take the 27 and raise it to the 2/3. These cancel. That's the beauty of it right there. Now think, cube root of 27 is 3. 3 squared is 9. Subtract 3 on both sides, x is 6. You need to check it. 2, and then 6 plus 3 raised to the 3/2 is that 54. So 2, and then we've got 9 to the 3/2. Well, the square root of 9 is 3. 3 cubed is 27. If I double 27, yes, I do have 54. This checks. My answer is good. Okay, so but get in the habit with these of checking your solutions. Now, this is where they get more complicated. Do you see that on the other side of the equation, you actually have an x? It's not just numbers, not just constants. When you have a variable on the other side, it definitely adds to the intensity of the problem. And what we're going to do is we're going to stop this video here, and I'm going to pick these problems up in a new video. Okay? So I will see you in the next one.